Hello, my name is Bob Plankers, and it's my pleasure to show you the Virtual Trusted Platform Module, or vTPM, a workload security feature that's found in VMware Cloud Foundation and VMware vSphere. Before we get started, I want to talk just briefly about trusted platform modules. For workloads and operating systems, they serve three important purposes. One is as a secure enclave for secrets. The workload can store secrets in there and can be reasonably certain that those secrets are hard to recover. Two, it serves as a machine identity. There's a key called the endorsement key that is permanently burned into the trusted platform module when it's manufactured, and that can be used to identify the machine. That's helpful in many regards as well. Third, the trusted platform module contains a random number generator that can be used for entropy. It's a good source of entropy or randomness to seed in operating systems random number generators as well. We need these things. We need randomness in order to power cryptographic operations to keep our secrets safe. And so these three functions are really important. And more workloads are insisting on having a vTPM available to them or a TPM available to them. Our answer in the virtual world is the vTPM, which is a fully TPM 2.0 compliant implementation. The workloads don't know the difference between a physical TPM and a virtual TPM in this regard. On VMware Cloud Foundation and VMware vSphere, the TPM, the virtual TPM, is implemented using a little bit of VM encryption. So we need, as a prerequisite, we need a key provider. We've got a demonstration and materials on configuring key providers that we urge you to take a look at. For the purposes of this demonstration, we can take a look to make sure that there is a key provider available to us. So we select the vCenter server object from the inventory browser, and then configure, and then key providers. And we can see that there is a native key provider installed. Its status, it's got a green check mark. It's active and ready to go. So in order to add a trusted platform module to a workload, the workload has to be off in order to enable it. Trusted platform modules are not a hot swappable component, even in the physical world. So this would be true in the physical world as well. But to enable virtual machine encryption, VM encryption, it does need to be off to start with. So we can select it. It's already off. We go to Edit Settings. If it's running a compatible guest operating system and a key provider is configured, when you go to add a new device, Trusted Platform Module will show up. If you get to this point and you do not see Trusted Platform Module, check to make sure your key provider is configured and operational, and check to make sure you're running a supported operating system. Most recent versions of Linux, all supported versions of Microsoft Windows should enable this here. If you're doing troubleshooting, you can just create a brand new Windows Server 2022 virtual machine, and that will have all of the prerequisites on the VM side, and that will help you identify whether you've got a problem with your key provider or a problem with a VM configuration. In this case, we're good to go. We can go ahead and add a trusted platform module. We see it added here under security devices, and we can say, okay. What will happen is this encryption here will switch from not encrypted to, say, encrypted with native key provider. This means it didn't encrypt the whole VM, it just encrypted certain configuration files. In particular, there's an NVRAM file that is in the home directory of the virtual machine. That is encrypted, as well as the swap files as well. But the VMDKs are not currently encrypted. You could go one step further and add a storage policy to enable VMDK encryption as well, but you don't have to. They all work very well together. This vTPMs also work very well with vSAN encryption too. So we could go ahead and turn this on. I will do that in a minute. I want to show you one other thing though. If you add a TPM to to a template VM or to something you're going to clone, the TPM, you may want to not copy that TPM. In certain cases, you might want an exact copy, but if you're deploying new hosts or new workloads rather, you will want a new TPM with a new endorsement key to have a separate machine identity, right? In vSphere 8 and newer, When you pick clone and you clone a machine with a TPM, it will prompt you for what you want to do. In this case, I'll create a second Active Directory VM and then the TPM provision policy. An advanced parameter in vCenter Server controls what the default is here. For a new, like I said, a new VM, you may wish to pick replace, where you'll get a completely blank TPM, and that'll be good. However, it won't have anything stored in it. All the secrets will be gone because it will be new. So keep that in mind. In most provisioning instances, that's not a problem. If you want an exact copy of the workload, you should pick copy. But in this case, we'll pick replace. I'll continue on and just go ahead and let the copy complete. We can power on this machine. And for the sake of speed here, I'll just skip the recording forward a little bit. And we can go in and take a look at what the device looks like in Windows. Device Manager, Security Devices, a Trusted Platform Module 2.0, just the same as what would happen on a physical host. From here, you can turn on Microsoft Device Guard, Credential Guard, HVCI, any of the advanced security parameters and features that could use a Trusted Platform Module. BitLocker as well, though if you're going to do BitLocker, you should consider using VM encryption or vSAN encryption and the possibilities there as well. So at any rate, this concludes the demo. Thank you very much. Please see the links below for more information, including a questions and answers document around vTPMs, everything you might want to know, but we're afraid to ask. And thank you. Thank you very much. Have a good day.